With a gravitational field so strong that not even light can escape its grip, black holes are probably the most interesting and bizarre objects in the universe. Due to their extreme properties, a theoretical description of these celestial bodies requires the use of general relativity, the theory proposed by Einstein in 1915, which treats gravitational fields as deformations in the fabric of space-time. Black holes are usually formed from the collapse of massive stars during their final stage of evolution. Therefore, when a black hole is born, its mass does not exceed a few dozen solar masses. However, once formed, a black hole begins absorbing the matter around it. And if it resides at the center of a galaxy, where the density of matter is high, it can grow up to millions and even billions of solar masses, becoming a supermassive black hole. Our Milky Way also hosts such a black hole called Sagittarius A, which is more than 4 million times heavier than the Sun. Although Sagittarius A is a giant compared to any other object in our galaxy, it is dwarfed by some other known black holes called ultramassive, which are tens of billions of times the mass of the Sun. While staggering, these behemoths pose a serious challenge for scientists. The problem is that according to the current theory of the formation and evolution of galaxies, no black hole should have had enough time to gain such a huge mass, even if it formed shortly after the Big Bang. But, what is the recent discovery made by Hubble? Scientists using the ever-faithful Hubble Space Telescope believe they've spotted their most terrifying discovery to date: a rogue, supermassive black hole, unshackled from the heart of its galaxy, prowling across the cosmos at nearly 1,000 miles per second. If their findings hold water, it would make for some of the best evidence to date of a supermassive black hole being ejected from its host galaxy. "It's a very cool, serendipitous discovery," says astronomer Charlotte Angus of the University of Copenhagen. "The possibility that this might be due to a supermassive black hole that's been ejected from its galaxy is very exciting. These events have been predicted by theory, but up until now, there's been little evidence for them." While looking for colliding dwarf galaxies with the Hubble Space Telescope, astronomer Peter van Dokkum and colleagues spotted something peculiar: a long, straight line that seemed to extend away from a distant galaxy, growing narrower and brighter as it went. "Whatever it is, we haven't seen it before," says van Dokkum. "Most astronomical objects are shaped like a spiral, or a blob. There are not many objects that are just a line in the sky. When astronomers do see lines, they're usually from something moving, like a satellite crossing the telescope's field of view." To figure out what it was, van Dokkum and colleagues took follow-up observations with the Keck Observatory in Hawaii. Those observations showed that the streak was associated with a galaxy whose light took about 8 billion years, more than half the age of the universe, to get to Earth. And this supermassive black hole isn't only destroying everything in its path. Based on the Hubble images, it appears the rogue black hole is producing a trail of nascent stars as it passes. You read that right, it may actually be spawning stars too, rather than just destroying them. In fact, this streak of stars is what led to the rogue black hole's discovery in the first place. Because a black hole is invisible, astronomers must observe the matter it surrounds itself with. In the case of supermassive black holes, that'd typically be a luminescent disk of gases and stars. But in the case of this rogue supermassive black hole detached from any galaxy, it, fortunately, left some sidereal breadcrumbs for astronomers. "I thought that I'd actually made an error, that there was this weird streak in the image," van Dokkum told Insider. "Black holes on their own are invisible. But if a black hole leaves a galaxy, it doesn't leave by itself. Some of the stars and gas that were gravitationally bound to the black hole leave with it. That gas will emit strong radiation that telescopes can detect. The black hole's path through the gas and dust in the galaxy's outer regions can compress some of that gas into new stars, too, which would also be visible. Another possibility is that the line is a jet of radiation launched by the galaxy's central supermassive black hole. But that scenario would probably lead to a beam that is narrow when it is close to the galaxy and broadens as it gets farther away. This streak does the opposite. If it's a black hole, it could have been ejected from the galaxy's center by interacting with one or two other black holes nearby. Almost every galaxy has a supermassive black hole at its center. When galaxies merge, their central black holes also eventually merge. If the conditions are right, that merger can give the resulting black hole a kick, sending it flying away at high speed. Alternatively, the black hole could have been spat out of a smash-up among 3 galaxies. When a third galaxy joins an ongoing merger, 3 supermassive black holes jockey for position. One black hole can be tossed out of the galactic smash-up, while the other 2 take off more slowly in the other direction. That's what Van Dockum thinks happened in this case. There are signs of a shorter, dimmer streak heading in the opposite direction from the bright, straight line. More observations of this system, perhaps with the James Webb Space Telescope, are needed to confirm that it really is an ejected supermassive black hole. JWST is one of the most advanced space observatories ever built, and it is set to revolutionize our understanding of the universe. NASA's James Webb Space Telescope is currently the most advanced space telescope around, with cutting-edge technology and advanced tools to let it see farther into the universe and see in much greater detail than ever before. Yet again, more theoretical calculations of what a runaway supermassive black hole should look like would help too. The finding motivates Angus to search through archived data for more potential black hole streaks. I wonder if there are more of these features out there, sitting in someone's data that might have just been missed, she says. Now that we know what to look for, these very thin streaks, it makes sense to go back to Hubble data. We have 25 years of Hubble images that have not been searched with this purpose, he says. If there are more to be found, I think we can do it. That's it for the video. Tell us in the comments section what do you think about this black hole. As always, thanks for watching our video. See you in the next one.